This video is on solving rational equations. We're going to look at two different methods for solving rational equations. The first one is using a skill you're already quite familiar with, using the LCD, the lowest common denominator. So just like when we simplified rational expressions, adding and subtracting, we need to first identify the LCD. In this case, I hope you see that the LCD is 2n squared, because we could turn each of these denominators into that denominator simply by multiplying by whatever is missing. In the first fraction, I need a 2, so I'll multiply by 2 over 2. In the second fraction, I need a 2 and an n, so I'm going to multiply by 2n over 2n. And in this last fraction, I have everything I need, so I don't have to multiply by anything. Okay, so we'll follow our same rules that we did before. I end up with 2 times 1, which is 2, over my LCD, plus 2n times 1 is 2n over my LCD. And this last fraction is just the same because it already had the denominator I needed. So the trick with solving an equation is once all the denominators are the same, the numerators have to follow the number sentence. If the denominators are the same, 2 plus 2n has to equal 1. So once you get the same denominator, you can just use those numerators. Don't forget that there's a plus there and an equal to here. That tells me that 2 plus 2n is equal to 1. I can solve this equation for n by subtracting 2 from both sides. That gives me 2n is equal to negative 1. And then dividing both sides by 2, which tells me that n is equal to negative 1/2. This is my solution, and if I plugged negative 1/2 in for all the n's in the original problem, I would get a true statement. There is one extra thing you have to look for when dealing with rational equations, and that is extraneous solutions. If you recall from radicals, extraneous solutions occur when the answer you got doesn't work in the original equation. Well, what's not going to work in the original equation is anything that would cause the fraction, any of them, to be undefined. Do you remember what causes a fraction to be undefined? I hope you recall that 0 cannot be part of the denominator, or not be as a denominator, which means that n squared can't be 0, n can't be 0, and 2n squared can't be equal to 0. This tells me that n, in this case, in this equation, cannot be equal to 0. Now, sometimes making n some other value would cause the denominator equal to 0, so it's not always this. You're looking for what value of the variable would cause the denominator to be equal to 0. Since n wasn't 0, it was negative 1/2, we're okay, and that is our solution. We should run into another one of these that may make more sense the next time around. Let's look at another one. We want the LCD. To get it, we need everything in factored form. So I look at this first denominator and the last denominator, and I know that those can be factored as m times m minus 1. I hope you see it also. So I can replace those denominators. And now looking for my LCD, I know I need a plain m, because all of my denominators have that, and I need an m minus 1, which I can see this middle piece is missing. So luckily, there's not a whole lot to change here because my first fraction and my last fraction already have the LCD. I am missing an m-1 in this second fraction here. So I'm going to multiply m-1 on top and bottom. This gives me 1 over m-1 plus, now remember here I multiplied, so I have an m-1 on top times 1 doesn't change anything, and an m-1 on the bottom. And this is equal to, and the last one didn't change either, so I have 5 over m-1. Now that all of my denominators are the same in the entire equation, I can take and make a new equation just using the numerators. Don't forget to not to move your plus or minus or your equal to. So I end up with 1 plus m minus 1 is equal to 5. Well, look at what happens to your 1's. I have a plus 1 and a minus 1. When I combine them, they're 0. And so m is equal to 5. In this case, as well, I can't have any of my denominators equal to 0. That tells me a couple of things. I can't have this first denominator, m times m minus 1, that can't be equal to 0. That means that m can't be 0, but also this part can't be 0. So m can't be 1 because that would make this part 0. Do you see it? So these are the two excluded answers. If I got one of those answers here, I'd have to cross it out and say it was extraneous. In this case, I got m is 5, and that'll work. It's not one of the exclusions. I want you to try this last one on your own. Be careful when you do it, the LCD has to apply to this fraction as well. Well, it doesn't look like a fraction, does it? Don't forget, anything that's not already a fraction could be put over 1, and you will need to apply the LCD to this part of the equation as well. Pause the video and try this one now. Okay, there was a lot going on here, so we need to make sure that you understood what happened. The first thing is that check your final answer. I got 4 and -1, 2 solutions, and that's because when we made our equation after we got a common denominator, it turned out that that equation was quadratic. Right here in this line, you can see that we have a squared term. Anytime your final equation has a squared term, you have a quadratic and you need to factor and solve. This will result in 2 answers. You still have to check if either of those answers are extraneous by looking at the original denominators and making sure that whatever values would make those denominators equal to 0 is not one of your solutions. 0 and 2 are the things that would make these denominators equal to 0. And so my answers ended up being 4 and -1. I'm safe. There are 2 solutions in this case that would make this number statement true. Look carefully at the work and remember to jot down any questions that you have for in class. The second method that we're going to talk about involves getting rid of the fractions completely. We're still going to use the LCD, but a lot of students tend to like this method because beyond the first step, the fractions go away, and most students just don't like fractions. The downside is that it's learning a whole other method, where method number 1 really uses what you already know about finding a common denominator. Let's take a look at what the LCD is. In this case, the LCD has to use both of these denominators. So there's a 3x plus 2, and there's an x. If you multiply every piece of the equation by this LCD, something special will happen. Let's take a look. If we multiply just once now, not over itself, 3x plus 2 times x, and it's always going to go on top, and an x and a 3x plus 2. What's going to happen is that you're going to extend those fractions. And remember, anything over itself cancels. And so this x and this x will cancel each other. Not only that, but this 3x plus 2 and this 3x plus 2 will cancel each other. Remember, only entire expressions can cancel. But if you look, all my denominators canceled. They're gone. And so this is really useful because what I'm left with on top on the left side is a 4 times a 3x plus 2. And on the right side is just a 6x. And now you have this equation without any denominators. You can distribute the 4 and then solve a normal equation. Go ahead and finish this problem on your own, pause the video, and when you come back, you can check the rest of your answer. All right, how did you do? I hope that you got x is equal to -4/3. One of the common errors here is subtracting 6x from both sides and then somehow wiping out the right side of this equation instead of putting a 0 there. If you choose to minus 6x from both sides, you have to put a 0 on the right because everything went away. There's nothing left. 0 is a number and it counts. Instead of that, I usually choose not to wipe everything out on any side of an equation. And so if it's going to make it happen, I move the other thing, in this case the minus 12x to both sides. I did check for extraneous solutions. I have x can't be 0 because of this denominator. And I have 3x plus 2 can't be 0 because of that denominator. And I went further to solve that, subtract 2 from both sides and divide by 3 to find out exactly what x can't equal. It turns out my solution was not either one of those, and so it checked out and there were no extraneous solutions. Here's another one I'd like you to try on your own. Make sure you identify the LCD, multiply it here, here, and here. Remember, we're getting rid of the fractions, so only put it on top and then cancel anything that's common with the bottom. Go ahead and try this one on your own now, pausing the video and checking your work when you come back. Okay, so the key to this is really picking the LCD properly. I do want to point out that when you multiplied 4b squared to each fraction, you'll notice that you had in this one a 4 over a 2. It is appropriate to reduce those numbers. 4 over 2 is equal to 2 over 1. The idea is all your denominators should cancel. If they don't, you either pick the wrong LCD to begin with, or you didn't cancel something that you should have. The whole denominator of all of the fractions in the problems should cancel out. If they don't, go back and reevaluate what your LCD was. I'm going to leave this one for you to try on your own. You should copy it down and be prepared to ask questions and check your answer in class. In summary, you need to be familiar with both methods, but then pick one and stick with it. It looks like I'm going to run out of time, so make sure you pause the video and get your summary copied down.